All right. So let's see. First question for 14.5 is number 30. I don't know, Rick. Log base 3. So how would you do this in your calculator?
Log 78 divided by log 3.
Yeah. Okay. Or you could use log 78 over log 3, or ln 78 over ln 3. They're the same. And real quick, I had a really good question from somebody. This does not mean that log 78 equals natural log of 78. And that's such a weird thing for students. If I said a divided by c is 2 over 5, you cannot say a equals 2. You can't. A could be 4, as long as c was 10. All this means is that it reduces to that number. So whatever these two are, they're not the same as these two individually, but the ratio is the same. That's the key. It was a really good question. This is a generally weird thing for students to understand. This will become big in pre-calculus, where you don't want to make this mistake. Okay. I don't know. Is that good enough for whoever asked that question? I mean, that's. And then you just plug this in the calculator, right? Okay. 42. Oh, okay. Wow. Remember what I said about this? If you have to graph these, you don't have to use translations. It's hard enough to do e to the x in the first place. But what's a smart thing to plug in for x that you actually don't even need a calculator for? 0. And what's the output then? 3. I like it. So 1 plus 2 is 3. And then if you plug in -1 and 1, you just plug it in the calculator. You get what the hell it says. You would just approximate it as a decimal. Right? Because if I said, what's e to the third power, it's not like me asking you, what's 3 to the third power? 27. What's e to the third power? I don't freaking know. It's less than 27. So you just do the calculator to approximate it with a decimal and plot that. Is that cool? Is that cool? Or understood? You guys are like, none of this is cool, man.
Here is the domain is always negative.
Yeah, so now the domain of any exponential function, the domain of anything, 3 to the x, 5 to the x minus 2, as long as it's nothing freaky, it's a little evil. I mean, as long as it's like e to the x, 5 to the square root of, well, that's what I'm thinking of. If it was 5 to the square root of x, oh shit, what can't happen to x now? Yeah, so only if something weird going on with the x, but this is just x. I could raise e to any power I want. So the domain for any exponential where nothing weird is happening to the x is all real numbers. It's negative infinity to infinity. What's the range going to be? Where's the asymptote now?
2.
Yeah, the asymptote is y equals 2. Good, so then that's almost the lowest. So it would be 2 to infinity with a what on 2? Yeah, because that's an asymptote. You can't get there. I like it. Okay. Holy shit, I think I'm doing everyone. 49. It's the same thing. I don't know what you want from me. So 40. I already answered 49. 63. 63 is ln. I think it's plus 2. Yeah. So again, now let me see if you guys can understand. What can you plug in for x that you don't need a calculator for? No, I don't know what natural log of 2 is.
-1.
-1, because I know what the natural log of 1 is. So when I plug a -1 in, I get a natural log of 1, which is 0, because anything to the 0 power is 1. Cool. If you understood everything I just said, you're in a decent place. If you didn't, say something. Or shake your head, sure. Yeah.
How does -1 become?
So when you plug a -1 in, you don't have to do it all in your head if you don't want to. You plug a -1 in, what does this become?
1.
And the natural log, any log of 1, think about it. What do I raise the base to make it 1?
0.
S. So when you plug a 1 into any log, and be careful when I say when you plug a 1 into the log, to make this 1, x actually has to be negative 1. If I made x 1, that would be natural log of, which I don't know what the hell it is, but again, once you get the 1 that you can do by hand, just start plugging other shit in there. The important thing here is, where does the asymptote go? Just like the important thing over there was the asymptote was very important, right? So where's the asymptote normally for a log?
What? 0.
The y-axis, x equals 0. It's normally there. What's this going to do? Move it to the left. 2. So now the asymptote is at negative 2. So when you get this point, negative 1, 0, and you put the asymptote in there, then you're good. Now at 0, it's whatever natural log of 2 is. Whatever, you can just get the approximation. Are you guys with me? So then you get the nice y-intercept. And maybe you can do one more point, natural log of 3, approximate it as a decimal, and you can plot it. Are you guys with me? What is natural log of 2? Somebody help me out. Somebody got that? Natural log of 2.
0.6931471.
So 0.7, okay. And what's natural log of 3? 1 point something.
1.09861.
1.1, okay, good. So 1, 2. So 0.7 is like right there, maybe. And then, where am I at? 0, and then 1. Let's see, that's roughly good. 1.1 is right there, so then I can fill it in. Bam, 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 bam. Okay.
X is greater than
Yeah, how do you find the domain algebraic? I mean, here you can see how it's easy. It just, the asymptote is a negative 2, so x got to be greater than 2. But how do you do it algebraically? X plus 2 has to be greater than 0. And you see how it's very much, well, how would you do this? What's this guy's domain? X plus 2 has to be at least 0. So again, logs and radicals are related in a lot of ways. Log is actually a little more restrictive. It can't even handle 0 inside. Poor little dude. Well, it can't. If you're empty inside, you probably can't handle that. I know. Alright. Let's see. Alright, so that's what I have for 14.5. Anything else from 14.5? Have you guys done 14.5? I like everybody's looking at me.
It was fast, all around. All copy.
Kick ass. 14.6, number 30. Oh, number 30 is almost. There's something about number 30 that makes it so damn easy. But as students, you get so wrapped up, which is good. It's good to get wrapped up in the algebra, but sometimes you got to step back and see what the problem's really saying. Now, everybody see the obvious thing to do first. It's kind of like a theme. Yeah, so wherever the x is, you get the other shit out of the way, right? If it was the square root, I would move the 4. If it was 4 plus absolute value, I'd subtract the 4. If it's 4 plus something with x, I'm going to subtract the 4. Get that thing out of the way. Now, can anybody... It's got to be 5 times... This has got to be... This... I can divide by 5, right? So that's got to be 1. And what's the only ways you can raise something to a power and make it 1?
0.
So the x has got to be done. Yay. You don't have to do any weird shit. Now you could take natural log of both sides. What's the natural log of 1? 0. What's the natural log of e to the 4x?
4x.
Bam! 4x. 4x equals 0 divided by 4. So you can see from the very beginning, 4 plus 5 is 9. So if that was 1, it would work. What makes that 1? X is 0. Hey, no work at all needed. Now you probably want to show me something, so I understand that you understand. All right, maybe. Oh, okay, so this got me going through each one. Maybe I won't do every single one. 35 is a good general one to talk about. I mean, how do I solve that?
E, you make it, and instead of line, EX equals 5. E to the 5 equals 6.
Sure, I like that. You could either think of this as e to the 5th is x, or what you really, this is going to be helpful later in math. If you raise e to both sides, what happens here? Cancel. So I get x equals e to the 5th. And of course, you get there either way you look at it. That was awesome. So very often when you have a log equation, you just have to rewrite it to solve it. We've seen that before. Bless you.
Thank you.
40 is the same thing. I'm not going to do it. 55 is a little bit different.
Oh, okay. It's kind of a long.
And here's where logs are not like radicals. They have neat properties that I can do more with them.
It's fun though.
Where'd it go? To be completely honest, there's more ways to solve this than what we do, but the way we do it is the most by the textbook way to do it. How do I do it? Yeah, see, so radicals, I want to separate them. Logs, I want to get them together because we have all these properties about what logs do with each other, right? The biology of logs. So if I subtract those logs, that log over, how can I rewrite this?
Log 4, x plus 2,
Who to what?
x plus 6 divided by x. Now you multiply everything by x.
No.
Oh no, equals to 4 plus
Rewrite it. Now I have a single log in an equation, and normally the way to solve it is to rewrite it in the other form. 4
It's the second
to
power.
the second power equals
X.
all this shit.
now.
So 4 to the second equals that. And then that, you multiply that up, get your x's on one side, blah, 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 yeah.
I was actually going to ask you because it was in my phone. So if it was like 3, like that log equals 3, then it would be 4 to the 3rd power.
So it'd be 64 here, yeah.
Okay, so like whatever it equals, you raise that to the power 2.
Yes, good, because we know that's what logs mean. This log is equal to 2, so 2 is the power that 4 needs to become whatever the hell that guy is.
Okay.
That's the meaning of a log, so that's why I can rewrite it like that. Just rewriting what it means. 64. 64, same thing. I just, instead of writing it as a quotient, I write it, so 64 is a plus in the middle, so I write it as a product, right? Now, what do you have to be careful when you solve log equations? What do you have to do at the end? Yeah, so if I got like an answer of 4 for x, if x came out to be 4, is that okay? Yeah, because here it would become negative, right? How about if x was 5, is that okay? No, because it can't handle a 0 inside, right? So it's got to be greater than 5. So you can even at the very beginning, I like it, some people are doing this, very beginning I just say x has got to be greater than 5. This is the worst piece, right? This x can be greater than negative 3 and this guy is okay. But this guy needs x greater than 5. Shit, so he sets the pace. So at the very beginning you can tell yourself what's got to be true. So if you get x equal to 1, you know to throw it out. Or you just check at the end, make sure it doesn't make anybody freak out. Okay. Oh, let's see, 70. Oh, 70 is in the calculator. Oh, good. Let's do this together. All right, here we go. This is, see how somebody had that same question, so it all works out. Oh, shit, well. Okay, well, it all works out. I should do that, just write it when I come in the room. Does anybody else have questions from anywhere else in chapter 14 while we wait? Yes, ma'am.
For the same portion, couldn't we make the x minus 5 be the exponent for 2, and then we know that the logs are the same, so we know that...
Oh, no. I see what you're saying. So are you saying put this 2 up here?
No.
No.
I'm saying that x minus 5 could be the exponent for 2, and then we know
That I don't understand. I thought...
the logs are the same, so we would have done like x plus 3 equals to 2 to the exponent x minus 5.
But how, I really don't understand how 2 plus log of this, how that can suddenly go up there. Is that what you're saying?
Yeah.
That there's nothing that says that could possibly happen. They're separated by an addition, right? The only time that something can go up to a power or come back down is when it is what? When can I make a number go up into a power or something? When it is the... Well, I like it. That's a weird question. So, the only way I can suddenly have a 2 show up here is if it started where? Yeah, as a coefficient. I think somebody tried to say that. So I can bring this back up and make it an exponent, because that's a property of logarithms. Because when do I multiply powers? When I have that raised to a power, so it can go back up. Right? That's the only time you can do it. In fact, log is the only function that has that property. Anything related to logarithms could have that property. Yeah. Oh, wow. Oh, that's the record tonight. Okay. Extra cables. It's like if you take your transmission apart and put it together, and you have like extra parts. Hopefully that's not. We'll find out. Why isn't smoke?
The car runs good or not? I don't know what this port is.
Huh? Yeah. Okay, well, okay, here we go. So I want to show you I want to remind you how to solve any equation in the known universe and beyond. At least to the point where you can get the real answers. Now, we've seen a lot of equations that have some real answers, some complex answers. We've seen equations that only have complex answers. So what I'm about to show you won't do shit for you in those cases, but I can find all the real answers for any equation by doing what we're about to do. So any equation you've ever solved ever in your whole life, you could check it by doing what we're about to do. Have I interested you? And we've done this earlier this semester, we just kind of forgot. Sorry, Midas. Do it enough and it works. Sort of like hitting the button on the crosswalk. It's like, dude, you hit it. It's going to happen. Alright, so that problem, this is problem number 70 in 14.6. And it says solve this, e to the negative x. So what you do, so the equation is, oh yeah, I've got to turn you around. The equation is this, e to the negative x, I said that like I remembered, minus 3 equals x squared. I desperately want you to understand, if you went to the tutor and you did not tell that poor tutor that there was a picture of a graphing calculator next to this, they will go insane because you cannot solve this by hand. It is, well, I've got to be careful what I say. There's a lot of ways to approximate this by hand, but you can't solve it exactly. Let me say it like that. Right? There's no way. There's no way. So if you go to some poor person and say, help me solve this, they will go insane. Like, why's your teacher giving you this? I don't know. And you're like, dude, are you a tutor, really? It's not their fault. You can't. You can't. So if they do, then you got to tell them because they deserve a prize. So what you do is, I don't know if you guys remember, what does this mean visually? This is a graph. I could graph this. I could graph this, and the answer is going to be where they intersect. All right, so if I make one side y1, e to the negative x minus 3, right? And I make the other side x squared. Now let's graph and see what my window looks like. Is everybody cool with me so far? So there's one side, there's the other side. You can do this with any equation you could imagine. And even some you can't. So hit graph. Let's see if we can see where they meet. So there's the e part, and here comes the x squared part. Hey! I can see it. Can you guys see it? Okay, sure. And I don't mean anybody playing along with your calculator. So this is hard to see now that they're both up there. But here's one equation, and here's the other equation. So this is obviously the x squared equation, right? So the answer is right there.
What are your numbers on?
I don't know. For some reason it's -3. Let me. If we all hit zoom 6, let's do that so we all have exactly the same picture. Oh, and if you want to, you might need this for the quiz too. Grab the calculator. So has everybody got this picture? That's playing along with me?
Yes, sir.
One slot. Make sure that, turn them on, make sure the batteries are good. The batteries good? Oh, you need one more. Okay, good. Make sure it turns on. Anybody remember how to get the intersection?
Yeah.
Second trace and probably the exact word I want. Yeah. And remember, there's a shortcut to this. Now, when you're finding zeros, it sucks because you've got a left bound and right bound and shit. But if you only have two graphs graphed, if you only have two curves on your screen, then you can do this shortcut. Put your cursor right on the answer, or as close as your human eyeball can tell, and then hit enter, enter, enter. Because the questions it asks are, what's the first curve? And when you hit enter, it bounces to the next curve in the list. I've only got two freaking curves. I'm set. And then the last question is guess. So if I just put my cursor right on the answer, I enter, enter, enter. Bam. So what's the answer?
Yes.
Beautiful. What's the y mean in terms of this question? Nothing. The y is meaningless in terms of this question. Guys understand? This question does not realize that this could be a separate graph and this could be a separate graph. So the graph it has a bunch of outputs. This equation only cares about the x values. It just says what x values makes these the same. So you'll get a y value. Don't put that down. I will take points off. That's not part of the answer. The answer is probably the variable that shows up in the same equation, right? Just the x piece. Okay, cool. All right. That's a really good question because you will have questions like that on the final. Yes, sir. Oh, good. Ooh, I think I was more evil. I didn't realize they didn't do that to you. Let me see if they do that to you. No? Oh, well. All right. It's a little bonus today. The quiz is harder than your homework. I'm joking. There's one question I might make extra credit. We'll see. Yeah, because this should not be synthesis. This is a standard. In fact, this question is silly. Normally, synthesis means it's harder. Why am I saying that that's an easy question? Not just because I'm the teacher. Yeah, the bases can be made equal. And then you can bypass logs, right? If you don't want to use logs. If you use logs, can you imagine how using logs on this problem would be difficult? Because you'll have an x on this side and a 3x plus 9 on that side. It gets a little bit unwieldy. I like that word. So now I'm looking through, let me see. I don't think they gave you one like that.
Oh yeah, we did.
That's too bad. Oh well. Yeah, so how do I do this? This is 86, by the way, I think, right? 2 to the third, so 2 to the 3x equals 2 to the 4, so it'll be 12x plus 36. Is that cool? Just bring the 4 through. 16 is 2 to the 4th, so the 4 goes through, blah, blah, blah. So this has to equal that, and you can solve it. Are there any answers that you would have to throw out? Is there anything you can't raise 8 to? No. So, because exponentials, their domain is all the numbers, right? It's only logarithms and radicals and rationals where there's a bottom, where the domain is limited. So that's the ones you got to check and make sure your answers are in the domain.
So, you just take out the same from each side? Like from 8, you took out 4?
No. 8. All right. So it's 8 to the x, right? But what is 8 in terms of 2? 2 to the what power is 8? 2 to the third power is 8. 16 is 2 to the fourth power. And what do I do with these powers? Multiply.
Okay.
And then since the base is now, I want you to realize something. So I think most of you guys, this makes sense. Since the bases are equal, all I got to do is make the exponents equal, and then the equation is true. If you don't like that, I can take log base 2 of both sides. What happens if I take log base 2 of both sides? That cancels. That cancels. So if you want a more algebraic reason why you're able to just make the exponents equal, that's why. If the bases are equal, I can just take a log base that, both sides, kill the base, and then I can focus on the exponents. So that's really algebraically what we do. Maybe. Okay. All right.
Wait,
Yeah.
so what's the answer for that one? The x and the 3.
You saw this. So 9x equals negative 36, so x is negative.
Oh, okay, yes.
How do you check that? Plug it in. This is an equation. So how do you always check an equation? Plug what you get in. I like it. All right. Anything else? Okay. All right, here we go. Put all your notes and shit away.
Oh, this one?
There should be enough room on the quiz, but you can have scrap paper if you want.
There's something weird in it. It's just
Scrap paper. Better not see any phones, iPads. I don't know, whatever.
no, it's just like faster.
Things that can access the internet.
You're left with. So then you have